Good day everyone, I'm Teacher TINZ and welcome to my YouTube channel. In this video, we will discuss about inscribed angle and arcs. Let us define inscribed angle and intercepted arc. An inscribed angle is an angle whose vertex is on a circle and whose sides contain chords of the circle. The arc that lies in the interior of an inscribed angle and has endpoints on the angle is called the intercepted arc of the angle. So let us consider now this illustration wherein we have circle G. So here, we will identify the inscribed angle and its intercepted arc. First, we have angle MSC. So, angle MSC is an inscribed angle wherein the vertex of the angle is located on the circle, which is point S. And its intercepted arc is arc MC. So, if this is angle MSC, if we will consider angle MSC, so its intercepted arc is arc MC. Another inscribed angle, so we have angle CSD. Angle CSD is an inscribed angle and its intercepted arc is arc CD. And another inscribed angle we have angle MSD. Angle MSD is an inscribed angle and its intercepted arc is arc MB. Let us discuss now theorems on inscribed angles. First theorem we have, if an angle is inscribed in a circle, then the measure of the angle equals 1/2 the measure of its intercepted arc, or the measure of the intercepted arc is twice the measure of the inscribed angle. So let's have an example. Let us consider now the given circle, and in the figure on the right, angle ECT is an inscribed angle and arc AT is its intercepted arc. So by applying now the first theorem, so if the measure of arc AT, the measure of this arc is 120 degrees, what is the measure of angle ACT? Again, if the measure of arc AT is 120 degrees, what is the measure of angle ACT? So here, the measure of the angle equals 1/2 the measure of its intercepted arc. If the measure of the intercepted arc is 120 degrees, so you're going to get the half of 120 degrees. Therefore, the measure of angle ACT is equal to 60 degrees. The second theorem, if two inscribed angles of a circle or congruent circles intercept congruent arcs or the same arc, then the angles are congruent. Again, if two inscribed angles of a circle or congruent circles intercept congruent arcs or the same arc, then the angles are congruent. So let's have an example. Let us consider now circle T. So this is now circle T. So in the figure on the right, angle PIO and angle PLO intercept arc PO. Since angle PIO and angle PLO intercept the same arc, which is arc PO, then the two angles are congruent. The third theorem, if an inscribed angle of a circle intercepts a semicircle, then the angle is a right angle. Let's have an example. So here we have circle O. So in the figure, angle NTE intercepts arc NSE. So if arc NSE is a semicircle, then angle NTE is a right angle, wherein the measure of angle NTE is 90 degrees. The fourth theorem, if a quadrilateral is inscribed in a circle, then its opposite angles are supplementary. Again, if a quadrilateral is inscribed in a circle, then its opposite angles are supplementary. So let's have an example. We have here circle M. This is circle M. And as you can see in the figure, we have quadrilateral DREA. So this is the quadrilateral which is inscribed in a circle. So quadrilateral DREA is inscribed in circle M. So we can say that by applying the fourth theorem, the measure of angle REA plus the measure of angle RDA is equal to 180 degrees. So angle REA and angle RDA are opposite angles. And when we say supplementary, the measure or the total measure of the angles is 180 degrees. So here we have angle REA and plus angle RDA is equal to 180 degrees. And then the other opposite angles, we have angle DAE plus the measure of angle DRE is equal to 180 degrees. Let's have illustrative examples by applying the four theorems on inscribed angles. So we will inscribe, intercept, then measure. So we have now here circle N. In the figure below, line segment CE and line segment LA are diameters of circle N. So these are now the diameters. Line segment CE and line segment LA are diameters of circle N. So if the measure of arc LE, this is arc LE, is 124 degrees, what is the measure of angle 1? This is angle 1, which is ACE. Angle ACE is angle 1. This one. So we're going to determine the measure of angle 1, wherein the measure of arc LE is 124 degrees. So for the solution, we can say that angle 1 by the way is an inscribed angle, is equal to 1/2 times the quantity of 180 degrees minus 124 degrees. Okay, so why do we have 180 degrees here? So here we have, this is the semicircle. Arc LEA is a semicircle which measures 180 degrees, and arc LEA is equal to arc LE plus arc EA. So here, in order to get the measure of the angle or the inscribed angle, we must determine first the measure of this arc EA. Okay, so we can get the measure of this arc by subtracting the measure of arc LE from 180 degrees. So we have 180 degrees minus 124 degrees, and the difference is 56 degrees. And then after that, by applying the first theorem, so the measure of this arc now, arc AE is 56 degrees. So we're going to get the half of 56 degrees, and that will be the measure of angle 1, which is 28 degrees. So the measure of angle 1 is 28 degrees. Let's have another example. We will use the same illustration or the same figure, which is circle N. So if the measure of arc LE is 124 degrees, the measure of this arc is 124 degrees, and we're going to determine the measure of angle 2. So this is angle 2. Angle LCE is angle 2. Angle LCE is an inscribed angle, and its intercepted arc is arc LE. So for the solution, angle 2 is equal to 1/2 times 124 degrees. So in order to get the measure of this inscribed angle, we're going to get the half of the measure of the intercepted arc. And the half of 124 degrees is 62 degrees. So therefore, the measure of angle 2 is 62 degrees. Let's have another example. We will use the same circle, which is circle N. And we have the measure of this angle is 28 degrees. Angle ACE is 28 degrees and angle LCE is 62 degrees. And the measure of arc LE is 124 degrees. We will determine the measure of angle 3. So this is angle 3, angle LAE. Angle LAE is an inscribed angle, and its intercepted arc is arc LE. So for the solution, angle 3 is equal to angle LCE by applying the theorem on inscribed angle. So since the measure of angle LCE is 62 degrees, so we can say now the measure of angle 3 is also equal to 62 degrees. Another example. So in the figure below, DREA, so DREA is inscribed in circle M. So this is DREA. And if the measure of angle REA is 80 degrees, what is the measure of angle RDE? Again, so if the measure of angle REA is 80 degrees, what is the measure of angle RDA? So by applying the theorem on inscribed angle, so since this is a quadrilateral which is inscribed inside a circle, so and then angle REA is opposite to angle RDA. So for the solution, we have now angle REA plus angle RDA is equal to 180 degrees. So we will just substitute the value of angle REA in the formula, and we have 80 degrees. This is the measure of angle REA plus the measure of angle RDA is equal to 180 degrees. And then next is we're going to apply the addition property of equality. We will add negative 80 degrees to both sides of the equation and then simplify. So we have the measure of angle RDA is equal to 180 degrees minus 80 degrees. So here we will simplify, or we will get the difference between 180 degrees and 80 degrees. So the measure of angle RDA is 100 degrees. Let's have another example. So we will use the same figure or the same circle. So we have quadrilateral DREA is inscribed in circle M. So if the measure of angle DRE is 60 degrees, what is the measure of angle DAE? Angle DRE is opposite to angle DAE. So the measure of angle DRE plus the measure of angle DAE is equal to 180 degrees by applying the theorem on inscribed angle. And then we're going to substitute the value of angle DRE, which is 60 degrees. So we will change this one into 60 degrees. And we have 60 degrees plus the measure of angle DAE is equal to 180 degrees. And then we're going to apply the addition property of equality. We will add negative 60 to both sides of the equation, and we have the measure of angle DAE is equal to 180 degrees minus 60 degrees. And we will simplify the right side of the equation. 180 degrees minus 60 degrees, so the answer is 120 degrees. So the measure of angle DAE is 120 degrees. Thank you for watching. Please don't forget to like, share, and subscribe.